Hello, ladies and gentlemen. My name is Miguel Moreno, and I will show you today my presentation titled Heterogeneous Data Systems Integration with FireDAC. First, let's take a quick look at the concepts that we will see today. What is data systems integration? The concept applies to the need to move data among different subsystems to make them look as a single system. Collecting concepts from different books, I have put together the following data system integration models: data transfer or interface model, data warehouse model, and reporting system model. In the data transfer or interface model, the data is sent in unidirectional, bidirectional, or multidirectional mode among all subsystems. In the data warehouse model, a data system is specifically designed to store the data from all subsystems, either in as-is form or in transformed form. In the reporting system model, the data is only integrated, merged, or combined at the reporting level. So no actual data is transferred among subsystems. Data integration transformation processes. Each data transfer between subsystems is taken care of via a connector or interface module. Data can be sent from one subsystem and loaded into another subsystem with few transformations, which would be a data type mapping only, or it can be fully transformed. When data transformation is needed, an extract, transform, and load process is in fact created. This is called an ETL. Types of data subsystems. If all data subsystems being integrated are built on the same database management system or platform, then we have a set of homogeneous data subsystems. These are easier to deal with since you can use the tools provided by the vendor to integrate them all. But if the data subsystems are built on different DBMSs or platforms, then we have a set of heterogeneous data subsystems. How to find a tool that allows you to easily integrate them all? Let's see how to integrate heterogeneous data systems. Let's see to the traditional approach first. In the past, implementing these ETL processes have almost always required custom coding in a high-level language, such as Object Pascal. Then you end up with a program that is hard to maintain, slow to change, and requires compiling, debugging, testing. Enter FireDAC to the rescue. FireDAC has a powerful, flexible, and extendable scripting capability that allows you to implement ETL processes using only SQL sentences and with the added benefit of scripting. That is, real-time testing and debugging. FireDAC has many built-in script commands. Start, to start execution of a specified script. Accept, it asks the user to enter a variable value. Connect, connects to the specified DBMS. Copy, move data between databases or text files. Define, it sets or shows the specified macro value. Delimiter, sets the script command's delimiter. Disconnect, disconnects from the DBMS. Execute, executes the specified store procedure. Exit, stops the script execution. Help, shows help for all registered commands. Host, executes a host or shell command. Pause, pauses script execution. Print, prints the value of the specified variables. Prompt, prints the specified text. Remark, adds a comment to the script. Set, sets the script execution parameters. Spool, turns spooling on or off, shows current status. Undefined, unsets the specified macro value. Variable, sets or shows the specified variable. All these commands are enough to create a powerful script with FireDAC already. In fact, these commands are used by the installation of the standalone FireDAC components and create all the data for the different database management systems. But what if you need to add a specific command? Or if you want to change the behavior of any of the built-in commands? Let's see how to extend FireDAC. To create a new FireDAC script command, you need to define a new class that inherits from fd script command. And then you must implement the following mandatory methods: the help function, the keywords procedure, parse function, and the execute procedure. The dump function is optional, only if you need to have the feature when monitoring remotely. Once your new custom command has been fully implemented, you must register it at runtime with the script command registry of FireDAC. FireDAC has the fd script command registry. It's a singleton class to add and register script commands. Here on the right side, you can see an excerpt from the code of FireDAC where it is registering all the built-in commands using fd script command registry. However, this class lacks a replace function to alter the behavior of built-in commands and to delete or disable a specific built-in command. Here you have an extended version of the script command registry. This singleton class can add, register, replace, and delete and register any script command, including the built-in ones. Here at the bottom, you can see a sample of 4 commands being replaced: connect, help, host, and copy. And also you can see 1 command being deleted from the registry, the shell command. This allows you to disable selectively those commands that you don't want your end users to be able to run, since all built-in commands from FireDAC are enabled by default. I will show you 4 enhanced script commands for this presentation. The connect script command accepts connection definition names and a local option besides the standard connection strings. Copy script command accepts text separator and delimiter parameters, can use connection definition names besides standard connection strings. Host script command. It waits until the host command has finished. If it is a text console command, the output will be shown embedded in the script spool or log. It works perfectly with any command line parameter combination. And finally, the spool script command. This version allows you to define an in-memory subscript that can later be called inside your main script. It avoids the need to write to disk the log. Conditional branching in FireDAC scripts. FireDAC does not support conditional execution. It's a script. But it has conditional variable macro definition only. Using the extended script command spool, you can emulate conditional execution by creating in-memory subscripts, then creating a caller subscript with an SQL sentence. SQL does have powerful conditional expressions that you can use either in the select or the where clause. But before I can show you some real-life examples of all these new commands, let me introduce you your best friend, the FireDAC script debugger. The FireDAC script debugger is a slightly modified version of the GUI, graphic user interface, script executor sample located in the following sample directory. If you have integrated FireDAC, which ships with Delphi XE5 and above, it'll be in the first directory shown. If you have the standalone FireDAC version, which ships with Delphi XE4 and below, it'll be on the directory shown at the bottom. So let's open the sample graphic user interface script executor located in samples, compiler, script GUI, script GUI. Once you have it open, we need to do some small modifications. First, you need to add these units, which provide the extended registry and commands that I'm showing in this presentation. Once you have added these units, you go to form create. These 3 lines need to be commented out. Here, this is up to you. I added to have my own font, my preferred font size. Also at the log or log output at the bottom of the form, you can have your preferred font. This one is key to enable the automated connect script command that I will show you. Since the program is using the connections that comes in the component, you must disable login prompt if you wanted to stop asking for the user password every time it tries to connect. The program by default has it enabled, but to be safe, I added in code to disable the login prompt every time the form is being created. This way you are disabling the login prompt permanently. Besides that, there's a small bug when saving new files. Also, to be able to execute a script even if you have not selected a connection. Normally, only if you have selected a connection here, this program will allow you to execute the script. But many times we are not connected yet. So you will add this line and comment out this one. In the run update method, the run by step update method, and that's it. So now that we have our best friend, the script debugger, I can show you how to create and debug enhanced FireDAC scripts. First, let's see the connections that we will be using in these sample scripts. Also, your best friend is the FireDAC Explorer. Here you can create connections by definition name. Your programs can use connection definition names in your FireDAC connection component, but normally the scripts cannot. But with the enhanced connect command that I just showed you, you can use a connection definition by name. So it makes it a lot easier for you to create a custom script. So we have this connection connecting to a device using an ODBC driver. We have a connection to an employee database. This comes from the interface sample database. We are also getting the DB demos, which are in MS Access, Microsoft Access format. We are connecting to an accounting system, which is under Microsoft SQL Server. We are connecting to an Oracle warehouse. And for all local crunching, we are defining an SQL Workdata database connection definition using a local file for all local crunching. These are the connection definitions that I will be using in my sample scripts. I will start with a simple script that will show you a couple of concepts to begin with. First, you will notice I'm not connecting to any connection yet, and that I'm using the enhanced connect command by using a connection definition name, SQLite Workdata, one of the definitions that I just showed you. And the commands are enabled with the modifications that we did to the code. One of the beauties of scripting is that you can step the execution and everything is done live. The command to do step execution is F7. I'll step through the first command. You immediately see the answer. So we know it connected. We are connected to this connection definition name. We didn't have to pass all the parameters to connect to this database. I'll step to the next one. This is a standard command. The next command is one of the enhanced ones. Spool subscript will make the following code spool the output, but to an in-memory script called procedure. Those used to using SQL Plus in Oracle are used to a similar trick, only that you always have to create a text file, an SQL text file in the local directory in order for this trick to work. Well, this enhanced version of the spool command by using the clause subscript will create the actual procedure but in memory. So you don't need to create text files. Let's step over it. You don't see an output yet, but these three outputs are being mirrored here, but at the same time are being spooled or output to the procedure one just created in memory. This version of the command ends the procedure that you are defining here. So we just created a procedure, a subscript procedure, and now we'll create a second one. The procedures are very trivial, but are made simple just to show you what you can do. Of course, your actual procedures can be much more complex with real commands. Okay, two procedures showed the output in the log, but at the same time were output to an in-memory procedure 1 and an in-memory procedure 2. Now this is Oracle style to call a subscript. FireDAC supports the Oracle standard and also the start command. They both work the same. Let's execute it, stepping over the first one. Script procedure 1 finished, and you can see this is the output coming from that subscript. Let's step over the second one. So you have both script 1 and script 2 being run from in-memory. You didn't have to create any text file. Let's go back to our script. And now let's do something more intelligent. We're going to create an in-memory subscript called run procedure. Script itself doesn't have much power for making intelligent expressions, but SQL does have intelligence for making powerful expressions. So what we're going to do is create the subscript called run procedure, and then with a select command from SQLite, create the procedure that we want to call. And this will be the output to the in-memory procedure subscript. This is a very simple expression, but it's just a way to show you that you in SQL can do any kind of powerful conditional expression to change the actual output that will be ending up in the in-memory script. So let's execute this one. Now we are starting the subscript run procedure. This select command created this output, which is now also mirrored into run procedure. We execute the end command. Now we have the run procedure in memory. So next step is to execute it. When calling run procedure, the contents of run procedure are on its own calling procedure 2. So it executed procedure 2 and put these three lines that come from procedure 2. Then again, it might look simple, but this is just to show you the power that you gain by being able to create subscripts in memory with this enhanced spool command. You must remember, though, that every time you issue the subscript command, you must end it, so the command knows when to finish the procedure in memory. Otherwise, you could run into some internal loops. Okay, after seeing that simple demonstration for the in-memory scripts, now we will see a real live full demo of a complex script grabbing data from several systems, doing a real heterogeneous data system integration. The script that I'm going to show you uses all these connection definitions that I just showed you before. We're talking about a legacy DBase database, an interbase database, a Microsoft Access database, a Microsoft SQL database, an SQLite for local processing, and finally an Oracle database that acts as a warehouse. All these are in place in this sample script that I'll show you. I have added prompts which actually give you a display on screen. If you add a command to spool it out, all these comments will also show on the log. That you can do manually here, or once you embed this into your final production system, the visual component for the script also has a property where you can define a log file. But what I wanted to show you is the beauty of how easy it is to test this complex script by doing everything live. So again, I have no connection, but I can start running the script. So even though I have no connection, you will immediately start seeing the output. These three commands are already showing up on the log. And I'll continue to process step by step. We are connecting to the accounting system in Microsoft SQL. Connected. Now, FireDAC knows the difference between Microsoft SQL and the other flavors of SQL. So it automatically changes the command separator to Go. Those used to Microsoft SQL know that that's the standard command separator. Since I want to have a single common command separator, I added a command to restore it to semicolon. And now we will extract the data from this table into a text file by using the copy command from FireDAC. Extracted. 642 rows were extracted. We continue. Now we connect to the DBase production system. We will extract first the data from the production target for the day. It will grab the data from the table and put it into a text file with all the data. 84 rows have the target data. Now we continue. Daily production, 924 rows have been exported. We continue now. Now we are gathering the employee data from the HR system, which is an interbase database. Connected, extracting data. We got data for 42 employees, 42 rows. Now we will connect to a Microsoft Access database that has the parts information. Connected. 59 rows were extracted. We continue. Up to now, what we have completed is the extract part of the process of extract, transform, and load. We have extracted from several heterogeneous data sources the data that we need. Now we will continue with the transform part of the process, which is transforming the data that we extracted. Now we are connecting to our local SQLite work database, where we will upload all the data and do the final crunching and processing. We connected. Now, these are the local tables that will hold the data that we extracted. The reason you see that we are dropping the table first and then recreating is that this makes the script completely independent, and regardless of which machine you run it at, they will always recreate the internal table, no matter what. From our experience, if you rely on the tables being created and residing already in the SQLite database, whenever you have the need to move the script and run it in another machine, it won't run because those tables don't exist on the local version of SQLite. So, a good recommendation is if you want to make your script completely standalone without any dependency at all, even in the local database, follow this strategy. It may look like weird while you're dropping a table and then recreating it, but it makes sense. This script doesn't need to have any ready-to-use SQLite database at all. So we will go on, drop the table, recreate the table. We upload the data that we extracted from the accounting system. Now we do the same for the production target table. We drop it, we recreate it, we upload the data from the database system that we extracted. Same we do with the daily production table. We drop it, we recreate it, we copy the data. Now the parts table, we drop the parts table, we recreate it, we upload the data that we extracted. We drop the table for employees, create the table for employees, upload the data. Now, up to here, we have uploaded all the data that we extracted. This next table is purely internal. This is a work table that will hold the last exchange rate. So this table is now a transformation. We will process the exchange rates table that we extracted, and we will get only the very last exchange rate that resides on that table. So we drop the table, we recreate it, and now we run this little script, this little SQL command that will extract the very last exchange rate sitting in the exchange rates table. Done. We got it. Now, this is another internal working table. This is the final one that we will be using to upload into our data warehouse in Oracle. We drop the internal table, we recreate it, and then this script you see here is fairly complex, but this is to show you that these kind of scripts are the ones that you can easily run here in this local SQLite database, which is collecting all the data from all the tables that we just extracted. So you can see the joins, calculations, is doing some labor rate calculation, some summary of production. All this is done through this one SQL select command. And the result will be fed into this temporary table that we just recreated. Let's go ahead. Done. Once we have our data transformed, now we need to upload the data into our final destination. So now we copy the data from this one table to an external file, and we are done with the transformation process. Now we skip to the last one, which is loading into our final destination. We connect to the Oracle warehouse, connected. Now we copy the file from the daily achievement per employee data file into the table that it's already in Oracle. Done. We uploaded 84 rows. This is a staging table. It only holds, is designed to be in Oracle to withhold the data that we just created. But then we need to append it to the final destination table, the historic data production achievement per employee. This is the final table that will have this data. So once we have uploaded into the staging table for the day, we do an insert to append it to the historic production per employee. Done. That's it. We have completed a full extract, transform, and load process by using only script commands in FireDAC. We extracted data from several databases, we transformed them, and then we uploaded them to a data warehouse. We just do the final steps of the script and disconnect. That's it. So far, so good. With the help of your best friend, the script debugger, and also of the FireDAC Explorer, we have created these scripts by just defining connection definitions and by using them in our script to be able to switch back and forth from connecting to different data sources. You can even check here and see the data that was created locally for your SQL work database. Here are all the databases that were created as part of the transformation process. But what if you want to test at runtime, at design time, if you want to test on your script component in your programs that you are designing? Well, this script won't run into the component, visual component of script in your program. The reason is that that component is precompiled, standard from FireDAC, and doesn't know of the extensions that we've been talking about here. The script debugger knows about them because we modified the code and we added the units that add the expanded commands. So, how to use these improved commands from the design mode in Delphi? Enter the enhanced script component. This is the enhanced version of the FireDAC script component. Here we can add the script that we just created. It's already here. The full script that does the extract, transformation, and load process. How do we know that it will run fine? With this component, the only thing you can do is validate and execute. But since the component is not tied yet to a visual component, how to know that it's running fine? Well, a quick and dirty way to check that it's running fine is by adding an output log. Script spool file name. And then you define to create the spool. On append will append it to an existing file, and on reset will recreate it and overwrite it from scratch. So we define this. We have the component ready to use, connected to a connection. Then we do execute. Right now it's doing all the steps that we just did manually. And how do we know that it runs successfully? Well, we simply need to go and open the spool file that was created. There you go. This is exactly the same log or spool file that we saw interactively when creating the script with the script debugger. So you can see all the steps that it took to extract the data, That's why the prompts help, the comments that I put in the script, because you can see the sections of what your script is doing. This is the portion that transforms the data. All the transformation took place successfully. And at the end, you can see that the transformed data is being uploaded into the Oracle database. So that's why if you want to have this logging activity in your program, it's very wise to use this feature of Spool. You can either manually put it in the properties for the script, as we just saw, or you can also use the Spool command. The Spool command allows you to, within the script, define where to create the spool file. Deploying your scripts in your finished applications. To deploy your scripts in your final application, the one problem you will face is that if you use connection definition names as suggested in this presentation, then you have two options to replicate and deploy the script in your final applications. The first and easiest option is to recreate the FD connection defs ini file within the FireDAC Explorer utility, or copy the file directly to the deployed machines. The location of this file is as follows. In the integrated version of FireDAC that ships with Delphi XC5 and above, the location is highlighted in the first line. If you have the standalone FireDAC version that ships with Delphi XC4 and below, you will see the location of this file in the line below, in yellow below. Your second option, which might be more secure if you're going to deploy the application in a more untrusted way, is to create the connection definition names in code at the beginning of your final application. As you can see in this little code window, this is a sample of how we create the procedure, create connection definitions. You just create a string list to hold the parameters. And then with 8 of the string lists, you create the parameters that define your connection definition. Once you have all the parameters for each connection, you call the FireDAC manager the method addConnectionDefinition, where the first parameter is the connection definition name itself. The second parameter is the driver ID, depending on the type of the SQL server you are connecting to. And last, the third parameter is the string list that holds all the parameters that you just defined. This way, you don't have to deploy any connection definition file. These connection definitions will be created on the fly at the beginning of your program and will stay in memory as long as the program runs. Once your program finishes, these connections are gone. This would be the way to deploy your enhanced script in a secure way. That's all, ladies and gentlemen. So we will follow to questions and answers.
Okay, here's a question. Is there an automation way to create scripts?
No, actually FireDAC gives you all those commands that you manually have to put together. What I just showed you on this presentation is that you can interactively develop them with the help of the script debugger, which is just the sample application that ships with FireDAC, only doing the changes that I showed in the presentation. This way you can interactively do, by trial and error, basically create your script. And once it works, you just copy and paste into your application. But automation to do this is, at least FireDAC doesn't have such thing yet.
Can these scripts can you run these scripts from command line so they can be integrated into continue integration servers or daily reporting services?
These scripts can be run with the console version of the script debugger, yes. So I'm glad you asked. I didn't show that specifically here, but if you take the script console executor that is right next to the script GUI version in the samples directory, once you go into that directory, there's two. One says script GUI, which is the graphic user interface, the one that I modified. And in the other directory is one called script console. That one is ready to go to be used as command line. The only one thing you need to do on that one is add the 2 units that I showed in the presentation. Once you add those 2 units, all these enhanced commands will be registered automatically, and there you go. You can call this command line version of the script executor.
This was very useful demo and typical of my day-to-day requirement. Thank you. Yeah, this was a great in-depth session. I got a lot out of it too. I didn't know you could do a lot of this stuff. Is the code of the modified example available somewhere? So this was, Miguel actually was talking to me about this while the video was running. So we're going to look, since this code is modified of the code that ships, we're going to look and see if maybe there's a way we can make this available as a, maybe for registered user download or something like that, so that, because we can't make it available to general everybody, because then it would be code that ships with the product. So we'll figure out a solution. Maybe
we'll figure it out and then have it available for everyone. Actually, that was the idea. Only Jim will help me to have a correct way to make it available to you.
So I'll tell you what I'll do, though, is if you tune into delphi.org, and I will post a blog post when we get the code posted. Or you can email me if I'm taking too long and say, Jim, where's it at? I need that code. Have we seen...
We have seen the last script using the command copy table to file that. That is the straight version of that command, where you say copy from table blah, blah, blah to file blah, blah, blah. And it's a simple way to do it. What you're asking for is whether I can use an SQL select command to do the extraction. Yes, you can. But then the copy command has a different syntax. It's copy SQL. Then you need to enclose the SQL in apostrophes. I'll make sure once we post the code available, I'll make sure I have an example of that version. Since that would make the things a little bit more complicated, I didn't show that here. But yes, I know exactly what you're talking about. Yes, you can use an SQL select command as the source of the left side of the copy command.
Okay.
Oh, by the way, I also forgot to tell you, I mentioned that in the presentation, but didn't show in the example. Also, you can avoid the need of switching the connections back and forth if you know what you're doing, because the copy command itself has optional parameters to define the connection definition name right next to the table. So without switching the connections, if you what you just want to do is extract from one single table or one single SQL command, and that's all you need to do, then you can save the switching of the connections by just including the connection definition name parameter on the copy command itself. I'll make sure to also have an additional example for just that case. Again, didn't do that in order to make the presentation more complex than it already is.
Okay, great. Can this strategy be used to create entire database structures on the fly or to maintain the database integrity?
That's a pretty good question. It would seem like yes, but if you see exactly what I was doing, you never actually extract the structure of the databases. You manually put it together. Of course, I use tools like, for example, for the interbase tables, the IB console itself gives you creates a select command for you or a create table command. So you just do a copy paste because you have these additional tools. If you took a close look at the desktop when I was showing, I had all these databases management utilities, the one for SQL Server, the one for Oracle, the one for Interbase, because you need them when you need this additional metadata definition. FireDAC itself does have some built-in functionality, but I didn't exhaust that feature here yet. I just relied on the database management utilities for each flavor of SQL.
If I design a database using a visual designer, can FireDAC create a script to use for recreating the database, not just the data on a different computer?
This is similar to the previous question. Then again, FireDAC has some powerful metadata extraction features. I know they exist. I have not focused in exploring those for this presentation. What I've been showing here is how to use DLM commands, data manipulation language commands, not data definition languages. Well, sorry. I did use DDL commands, data definition language commands, but those were created manually, as I said, with 8 of the SQL management tools for each SQL flavor. I'm not at this moment using, for the metadata definition, not using the built-in features of FireDAC. FireDAC is powerful because by extracting metadata definition, it knows which is your primary key or which value needs to be enforced. That's when you create your FireDAC scripts, those fields get automatically checked and the properties put together because of that. But I'm not exploring that feature for this presentation.
Okay, so it's something they could do, but it's just not something you covered in this presentation.
Correct. Could be done, but it's not covered.
All right, it looks like I think we got through all the questions. There was a lot of good information in there. Thank you so much for that.
Thank you so much.
Yeah,
I hope you have liked it.
Yeah, we'll figure out a way to get your code posted so everybody can take advantage of that. And if nothing else, at least they can watch the replay and learn from it again to pick up the bits they missed. So thank you very much.